Yesterday, when we talked about the immune system, some of you were curious as to why we get butterflies in the stomach. And I just wanted to let you guys know that it's caused by adrenaline. It's part of the flight or fight response caused by the adrenal glands, in which adrenaline is released and your heart rate goes up and you start getting active in preparation to flee. As part of that, the blood is diverted from your organs, like your stomach, to your muscles, and that causes the feeling of butterflies. I just wanted to tell you guys a little bit about a new technique that's being used to look at chromosomal abnormalities in fetuses. So Ms. Garcia was just talking about taking a sample using a needle into the amniotic fluid, which requires you to insert a needle through the basically what you would consider your stomach, into the uterus, and taking out some of the fluids in there. And of course that can be risky, so it can carry a risk of miscarriage, and for that reason a lot of women choose not to do it. Once they have that sample, they can easily look at whether or not there are chromosomal abnormalities. You guys were learning about karyotypes, and that's basically a picture of the chromosomes. So you can see here this person has the normal number of chromosomes, and if there were any abnormalities, it would be easy to see. You can also do a microarray, which is where you have a plate that basically has a whole bunch of little DNA probes in there, and so it can check whether or not you have the presence or absence and the abundance of certain sequences. It's basically kind of like when you were a little kid and you used to play with a toy where you could put the star and the square and the triangle into the holes, and if you put them in the wrong hole, it doesn't work. So the new method that doesn't require you to stick a needle into the uterus is massively parallel sequencing. So because of the exchange of nutrients between the mother and the baby, small amounts of baby's DNA end up in the mother's blood and vice versa. And so you can actually just take a blood sample from the mother, and then you can do this technique called massively parallel sequencing. Basically what you have is you have a little bead that has a bunch of probes on it to check for different DNA sequences, and so the DNA will bind to those little beads. Each one of the tiny holes inside of the yellow plates, so there are many holes on this plate, contains one bead, and then you have basically just one drop of DNA. And what you can do then is you run it through this machine. You guys remember the nucleotides. So there are 4 nucleotides in your DNA. Each one has a different type of energy, and so it will release a different type of light when it's put into this machine. And so you can go through millions of nucleotides in a very short amount of time, and you can very quickly check whether or not the baby has all of the chromosomes that it should have. And the reason why we still use the method of sticking the needle into the uterus is because, of course, it costs a lot more money to do this massively parallel sequencing. So maybe as technology gets cheaper, we'll actually be able to do it in a way where women won't have to be at risk of miscarriage to find out whether or not their baby has any chromosomal abnormalities.